16b students, here are a couple of improper integrals. Be careful though, these are the kinds where it's a little bit challenging to see. And somehow I've written this one wrong. That was supposed to be sorry, this is supposed to be a 4 in here, not an 8. The reason, so if it was an 8 in here, that'd actually be a problem because 4 minus 8 is negative, and we can take the square root of negative, and we have to, like, but everything between 4 and 8 would be, so that would just be weird, right? It shouldn't be like undefined where you're getting imaginary numbers, you're undefined and that you're like divided by 0. So that would be a strange problem. This makes a lot more sense. The integral from 4 to 13 of 1 over the square root of x minus 4. So clearly 4 is an issue, because if I plug in 4, I get 0 on the bottom, and divided by 0 is undefined. So write this as the limit as t approaches 4 of the integral from t to 13. And I'm going to rewrite this as x minus 4 to the negative 1/2. And I should be a little extra clear. T is approaching 4 from the which side? Well, it's got to be from the right side. Because if we're between 4 and 13, right, we are bigger than 4. Bigger than or equal to 4, which means we have to approach 4 from the side being bigger than it. Okay, so then we're going to integrate. You could do a use of, but letting u equals x minus 4, du is dx. It's not really that big a deal. I think you can just say, I know the integral of x plus or minus a number to a power. I can just use the power rule. So I'm going to get x minus 4 to the positive 1/2, right? Negative 1/2 plus 1 is positive 1/2, divided by 1/2 from t to 13. Now really, dividing by 1/2, I would actually start multiplying by 2. So here I'm going to see, alright, I get the limit as t goes to 4 from the right of 2 times 13 minus 4 to the 1/2 minus 2 times t minus 4 to the 1/2. Since I'm not getting division by 0, I can actually plug in t going to 4, and I'm going to get 2 times 13 minus 4 is 9 to the 1/2, or the square root of 9, minus 2 times 4 minus 4 to the 1/2. So 9 to the 1/2 is the square root of 9, which is 3. 2 times 3 is 6. So you get 6 minus 0 to a positive power, or the square root of 0 is just 0. So you get 6 minus 0, which is 6. So I would say this integral converges to 6. And it might be important to actually write that down if you're finding an integral being convergent. Okay, let's look at this next one. The integral from 0 to 8 of 1 over x minus 6 cubed. So you have to be extra careful here because it's not undefined at the endpoints, but it is undefined at a point in between, which is 6. So you have to break this up as the integral from 0 to 6 of 1 over, actually I would rewrite it as x minus 6 to the negative third, because I know it's going to be easier if I do it that way. Plus the integral from 6 to 8 of x minus 6 to the negative third dx. And then you can do, you have to do, well, you don't have to do both of them. You have to do them, you have to do them each other. There's a word I was looking for. You have to do them single-handedly. I don't know. You have to do them not simultaneously. There's a word I thought I knew that started with S, where you have to do them, I don't know, singly. That seems weird. Anyway, so I'm going to do it. I'm going to do the, either one. I'm going to do this one first, because I wanted to show you what happens if the upper limit's the problem. So we're going to do the integral from 0 to 6 of x minus 6 to the negative third dx. I'm going to write that as the limit as t approaches 6 from the left, right? Because if we're between 0 and 6, we are less than 6 of the integral from x minus 6 negative third dx from 0 to t. It is important to write this limit. If you don't do this step, I bet you would get marked off. And then you're going to integrate, again, since it's just x plus or minus a number, we can just use the power rule and get the limit still, t approaches 6 from the left, of x minus 6 to the negative 2 over negative 2 from 0 to t. Now, after I integrate, I kind of like to replace negative powers or bring them to the opposite place they are so they become positive. So I would really rather prefer to write this as the limit as t approaches 6 from the left of, I don't like the negative sign on the bottom. I might write that in front as negative 1 over 2 times x minus 6 to the positive second power. Right, that just seems a little bit nicer to me from 0 to t. The 2 doesn't come up on top, right? Just the 2 says on top. The negative can either go on top or on the front. So then we're going to plug in the limits of integration. But the limit is t goes to 6 from the left of negative 1 over 2 times t minus 6 squared minus negative 1. So I do a minus and minus as a plus, but you do minus negative 1 over 0 minus 6. Oh, sorry, 2 times 0 minus 6 squared. And now I can see that when I plug in 6 for t, I get 6 minus 6, which is 0. 0 squared is 0, but 1 over 0 is going to be undefined. So this is undefined. It's going to negative infinity because this part here, since it's squared, is going to be positive, but it's a negative up front. And this part doesn't matter once this part's going to, I mean, this part is finite. So since this part diverges, we get to say the whole thing diverges. We don't even have to look at what this other part does. It also diverges, but it doesn't matter. So I would say this whole thing diverges. Now, I can't say it diverges to negative infinity, because although this part diverges to negative infinity, this part might diverge to positive infinity, and then we don't know what the sum of those two things actually diverges to. So if you have a multiple part one and you know that one part diverges, you just stop there and say the whole thing diverges, but you don't talk about if it's negative or positive infinity. All right, that's it.